So when the input cycle is reverse bias, whatever cycle that makes it reverse bias. So in this case, the negative cycle of the input signal make the diode reverse bias. So reverse bias always means that you got to open that diode. That means whatever in the branch of the diode will be completely gone as indicated here. That's always the case in the reverse bias. But opening that branch doesn't make the entire circuit open according to the given circuit. Correct?
Why is it 5K over 15K? Why don't you add?
What do you mean by that? That's how the voltage divider is. Again, we can find out why that is, but that's not to this course. So, but that's how the voltage divider is. It's whatever the resistor of interest over the total resistance times the source. So that's how the voltage divider principle is. There are a lot of details that goes into these limiters. You really need to know the orientation. You really need to know what is forward bias, what is reverse bias, and how the orientation is, that the diode has positive on the top or negative on the top. So
what does the waveform look like?
So for the negative, since this one you are talking about negative cycle, so the signal will be pretty much, so I think I have something off here. So in the negative cycle, it's not going to do any clipping. So it's going to be straight. Since you don't see any diode behavior in the negative cycle, correct? So it's just a pure AC voltage coming in. So the signal on the negative cycle would be your negative 2.5 volts. So it's not a clipping, it's just an amplitude reduction because of this signal right here. Do you guys got 2.5? This is not right, right? How much is it? So as soon as I put that value, since these two are not equal, so how much you said? 1 point?
Yeah, 1.6. That's 1/3 times 5.
So the result would be, yeah, the positive cycle, since the diode is forward biased for the positive cycle just in this circuit, that's why the diode have 0.7 on it. So that's not going to change. As long as the diode is forward biased, it will have 0.7. But the question is, which cycle make it forward bias? That will change. It's a simple sign, yeah. Yeah, the second side, the one in the red color right here. You're talking about which cycle? You're talking about negative cycle. So that's a negative voltage right there. So whatever this 1.67 is, so you draw like a sine wave on the negative side. So this is your reference, for example. So this is your axis, right? So when you're on positive cycle, you will be clipped at 0.7. When you are on the negative, so when you say reverse, which one you're talking about? So in the negative cycle, what would be the voltage? Negative 1.67. That's on the negative side, like towards this way. On the positive side, it is only, it's still going to be 0.7. That is, I'm drawing two cycles. So positive cycle, is it open?
It's all the same signal coming through. It's just when it goes across that axis, it's now acting as a reverse bias.
See, positive cycle always makes that diode what? So what is the voltage on the diode? So wherever you see positive cycle, That would be 0.7 and that's it. Okay. Now when you're dealing with negative cycle, then the diode becomes reverse bias. Reverse bias means it is open. So you calculate, so when it is open, you remove that diode altogether. And now you use the voltage divider to actually find what that voltage level is. Since it came out to be 1.67 and you are under negative cycle, so it would be negative 1.67. That means whenever you see negative cycle, it will be negative 1.67. Whenever you see positive cycle, it would be 0.7.
If you had a different colored pen and drew it up on top, you could see the 0.7 at the top and 1.67 at the bottom.
Oh, this is for the same circuit.
Both are for the same circuit.
Oh, okay.
This whole thing is just for one circuit, but that is for positive cycle and this is for negative cycle. Right? So this analysis is just for this circuit because diode behaves differently for positive cycle or negative cycle.
That's why this one is not a rectifier.
Since it is connected in parallel, it is connected in parallel to the load. It's not a rectifier. Rectifiers are usually the diode will be in series with the load. But if you put a diode in parallel with the load, that would be a clipper, not a rectifier. No, clipper is not for AC to DC. You may get DC depending upon its clipping level because there is some DC in here too. Because you see the top portion of the signal right here is a straight line. So there is some DC content in this signal, but their purpose is not for AC to DC. But by doing clipping, there may be a possibility that you will get some DC voltage.
But it's better used to refine.
Not necessarily, that's probably not needed if the application is a clipper. So I'm going to quickly go over this again. So again, always remember that this analysis is only for this particular circuit and this whole thing will change if either diode is reversed. But what will not change is whenever the diode is forward bias, the voltage on the diode will be 0.7. Whenever the diode is forward bias, that's the only thing. Whenever it is reverse bias, that's easy to do because reverse bias means you take that branch completely off. Whatever that branch has, it will be completely removed. That means reverse bias on the diode will always require a voltage divider. That's one trick that you can think of using it. Whenever the diode is reverse bias, you can always take away that branch that the diode has. That's always going to give you a voltage divider. But what cycle make it reverse bias, that would be different. So I want you to think, again, I'm clearly saying it's only the diode perspective, not what cycle make it reverse bias. Do not think that negative cycle always makes reverse bias. No, that's not true. All right? Yes.
So if, let's say you have 15 volts as the power source, no resistor, where does the excess voltage go?
No resistor is, then it won't be the clipper. You must require this resistor right here. Even you need to, if you want a clipper, you need that resistor right there. What if you take that away? What the circuit would become? If I take that R1 away, how does all three components are connected? Yes, if I take that R1 away, all the three are connected in parallel. So what is same in parallel? Same voltage. So everywhere you will see that 5 volts peak. So that R1 is a must to have a clipper. You cannot remove that R1 and still expect a clipper. So the circuit will not be clipper anymore. Does that make sense?
So the first R1 takes away the excess voltage.
Excess voltage on the negative cycle and even on the positive cycle. That is correct. But we cannot get rid of that one. What?
So quick thing on the clipper. You said with the clipper, when you're dealing with the clipper, the resistor has to be in front of the diode and the load has to be behind the diode.
That is correct. There must be a resistor before the diode. The load must be parallel to the diode. That's a requirement even to have this kind of action. That means it's a requirement, it's a must for clipper. The whole circuit is called as a clipper, but the diode is heart of the clipper. The whole circuit is referred as a clipper, but without the diode, there would be no clipper. Right? Because as you can see on the positive cycle, the diode is forward biased. Voltage on the diode is only going to be 0.7, and that's all you are collecting on the load since you placed in parallel.
So it's clarify what you say is a negative cycle reverse bias.
That's not always true. In this circuit, it is because of the orientation of the diode.
You put the diode, the waveform would be the mirror image of it. Or if you put the diode, the negative cycle will be.
So let me give you another example of the same orientation. Again, you need to remember first what is forward bias and what is reverse bias before you even do this. So I hope you. So if a diode is like this, if the voltage coming is, so let me draw a DC, maybe. So what biasing this would be? Why forward? So that's the thing that you must remember. So what about now? So what is the orientation of the diode now?
Well, no, wait, it's open, so.
Again, we're not talking about what will be happening. This side is closed, let's say. All right, so here you say it's forward bias because positive on the positive side. So in here what? This is that's a reverse bias. Why? Negative on the source to the positive of the diode. That's a reverse bias. Because if you use an AC source, does AC source have only positive or only negative? It has both, correct? So the diode will be forward bias and reverse bias one cycle after the other, correct? So let's say that's my load. This is my resistor. Let's say this is like 10 volts peak signal. So let's say this is also a clipper. So let me quickly check something. Forward, depending upon on the other side too. It's usually forward. Yeah. Because on the positive side, it will be connected too. On the other side. This is probably one of your homework questions, I think. The one that you just asked, if you remember any. I think it's the 6th question, B or something. All right, so where do we start? So if you see a clipper, where do you even start?
Which part of the page?
So first, you need to realize that definitely whether the diode is forward or reverse bias. But since the source is an AC, there is no one way of telling it, because it's not always going to be forward bias. It's not always going to be reverse bias, because the signal will flip in the direction. Unlike the DC sources shown here, they are not going to change the direction by themselves, right? Unless we swap them. But AC signal is not like that. So that's why I split the problem always into 2 ways, which is going to be positive cycle and negative cycle. Again, this whole thing is just one problem. But for better understanding that we are doing it like this. But if you know well enough these clippers, you don't even need to do any math to even find out what the resultant signal is. All right, so you always split this problem into 2 half cycles. One is positive and one is negative. Again, this cycle is from the incoming signal perspective. Then you decide the orientation of the diode. So the orientation of the diode is, this is positive and that is negative. That's you need to realize by just looking at the circuit. Which side is anode and cathode, that you need to know. That won't change. Yeah, the given circuit will not change. All right. And then you find out forward or reverse bias. So now we are talking about positive cycle. What is the condition of diode? When I'm talking about positive cycle, the signal coming at like that, that's the given. When we are talking about positive cycle, that's the given direction. So what would be the diode? The diode will be forward bias, because that's positive to the positive. That automatically means negative cycle is reverse bias. You don't even need to think again. If once you decide forward, then the other would be reverse. If this is forward, that would be reverse. Yes, negative cycle could be forward. Positive cycle could be reverse. Again, all we are looking is positive to positive or negative to positive. Right? But it could be other way around in this case as well. So now forward bias, once you decide whichever side is forward bias, then the voltage on the diode will be 0.7, because we are interested in this branch only in forward bias, because it is connected in parallel to the load, right? So if I redraw the circuit, again, this is not necessary, but it may help you to visualize. So if I redraw the circuit, in the place of diode, I can visualize as it is a 0.7 volt source, where positive is being at the top because of the given orientation.
With that 10 VP voltage source, we just assume
That is given too. The voltage will be given to you. So
I mean, positive and negative. You're assuming that positive is at the top of it, negative.
since I'm talking about positive cycle,
Yes.
that's
Talk about, that's what I said. Talk about positive cycle. Then we're going to say
then that's why I put positive and negative right up there,
because we're talking about positive.
because I'm talking about positive cycle.
Even though if you
When I'm talking about negative cycle, then you can flip the direction around.
which doesn't like
Yeah. So in here, the positive cycle makes forward bias. Again, always keep in mind that may not be always true. But remember previously what we showed here? Positive to positive will make. That's all you need to remember to even think about forward or reverse bias. So now, what would be voltage on the load? Because it is in parallel to that branch, it would be 0.7. So when you are asked to draw, so on the forwards, on the positive cycle, you are going to draw that 0.7 volts, since it is 0.7. You're going to draw under the positive cycle of the AC signal. That's where you begin with. Reverse bias is always easier because what we said before, reverse bias means you can take away that whole diode altogether. That means you're going to end up with always a voltage divider. You don't even need to think twice. As long as it is reverse bias, you're always going to end up with using voltage divider, because the diode right here, reverse bias means the diode will be open. So the source is 10 volts. If it clarifies you, you can put that negative in the front, since you are talking about the negative cycle, not reverse bias. You're talking about negative cycle. That means the resultant voltage should be negative. So the voltage on the load, so what would be the equation? So the resistor of interest is 1K because it is the load over total resistance is 3.2K times 10 volts. You can even put that negative 2. It doesn't. But all you need to remember is you're talking about negative cycle. So what would be that result? So
So it's 1K over 3.2 because you're adding that to it.
that is correct, since they are connected in series. How much you said? 3 point? Okay, so something like this. And all you do is just draw a negative peak. Since you're talking about negative cycle, so the voltage would be negative 3.13. Reverse bias always means a voltage divider. So reverse bias always means a voltage divider. Forward bias is where you need to be careful, because the diode comes into the picture whenever it is forward bias. And the whole thing repeats because it is an AC signal, so you can keep on continuously drawing, but that's the resultant signal. What you can see here now, the peak to peak, like the peak to peak voltage, how much you think it is? Yep. So 3.83. But here the peak to peak would be what? No, that's 10 volts peak. So the peak to peak would be, you double the, right? You can see that that's a 20 volts peak to peak signal was clipped all the way to only 3.83 volts. That's a 0.7 on the top, 3.13 on the bottom. You add them together. So when you add those two, don't take that negative into consideration. So you just add those two. It should be around 3.83 volts.
When you're doing your math in the reverse cycle, oh yeah, you go.
Yep.
So, how can a negative cycle be forward biased? I feel like I know-
Forward bias. Again, we're not talking about any of that example yet. So we will talk about that in a minute later on. How come a negative cycle make it forward bias? But we already done that in so. But we will talk about that in a minute. What happens if you flip the diode around? The whole thing will change altogether. But what will not change is reverse bias always going to be the voltage divider. Forward bias always means you're going to deal with something related to that 0.7. Right? That won't change. So, but before we proceed, are we clear on this example or even the prior example? So I'm going to give you one more example before we take a break, but this is positive clipping, right? So this is the example for a positive clipping. All right, so since, did you see any clipping on the negative? Did you see any flat line on the negative? It's a normal cycle. Since there is no clipping on the negative cycle, it's only amplitude reduction, not a clipping. So that's why this is usually referred as positive clipper.
So in general, we got a clipper.
Yes, a clipper will clips the voltage. It's usually, you find that flat line, right? Positive. Yeah, this is just a shortcut for writing positive. Yeah. I never had that question before. Positive is it's like that VE at the end. So that's a quick way of writing positive and negative. You should have that question right here. It's just indicating that that's a positive cycle, negative cycle. So instead of writing that whole positive and negative term, so. All right, so